All right, so we started talking about naming branch-chained alkanes. What that means is we've got not just a nice single row of carbons, but we've got these branches that come off the sides of them, all right? And so we want to deal with how to name those particular ones at this point. And then we'll continue on and talk about double bonds and triple bonds, all right? We started a couple of examples, and so at this point, talking about the rules makes a little more sense after we've done one or two of them than just when we started, because it didn't have any sense. But identify the parent chain, and we did that for the first one. We'll do that again in a moment. But we always need to find that longest chain. The longest chain is going to define the main name, the parent name, all right? If it's cyclic, all right, the number of carbons in the ring is the parent name or the base name. So the ring defines that longest chain, all right? We don't actually find a long chain that maybe has a piece of the ring and then goes out the other side. The ring becomes the main part, all right? The number of carbons along the parent chain beginning at the end, which results in the lowest number of branches. So we give the main parent chain an address, a series of numbers, just counting them off. And we always start with the end that's going to give us our lowest numbers. And you can determine that visually by kind of looking at which end the branches are kind of clumping at. You can kind of see they're either at one end or the other end, okay? Name each branch. And when we say name each branch, we're talking about things like methyl groups, which is a CH3 missing one H that can then bond onto the chain, or an ethyl group, which has C2H, what would it be? Normally it's C2H6, right, because it's the 2N plus 2, but C2H5 would be the methyl group, ethyl group, et cetera, and we'll go over some of these. Write the branches in alphabetical order. If the same branch appears more than once in the chain, the quantity of identical branches is indicated by a prefix, di, tri, tetra, penta, etc. These prefixes do not affect the alphabetical order. Put everything together, number, and then a dash, then the branch name, then a dash, then the number, then the dash, then the branch name, depending on how many branches you have. We always separate numbers from words with a dash. Okay, so let's zoom in here so that we can see a little better here. And let's name some of these guys that we were dealing with here. So I'm going to move here off to the side. And I think we've already done this one, but we'll do it again. So looking at this particular chain, right, I see here 1, 2, 3, 4, 5, 6. So that's a 6 chain right there. I maybe think 1, 2, 3, 4, 5, but no, that's not the longest one. So 1, 2, 3, 4, 5, 6. So this is obviously a hexane, and I like to write that down already, hexane. That's my end part of the name. We start by numbering at the closest end, 1, 2, 3, 1, 2, 3, 4. So this is 1, 2, 3, 4, 5, 6. And here's our group right there. This is a methyl group, all right? It's at the number 3 position. So this becomes 3-methyl. And look at, I put a space in there, but that should actually go together as one. But you know what, if you leave a little bit of space in there because you put the base name first and then put the 3-methyl, that's good enough, all right? So that's 3-methyl hexane, okay? We encountered this one already, and I'm going to go quickly. I think we've got the answer to these, so I'm just going to go quickly through it. So we've got 1, 2, 3. It doesn't matter which way we make the chain. It is identical. I have 2 methyl groups, and you might think that I should put a number 2 to describe the position. But if this methyl group was on this end carbon, it would turn my propane into a butane. And so in this case, there's no need for numbers because you can't put a methyl on an end carbon. As soon as you put a methyl on an end carbon, you've extended the chain really by 1. So having a methyl on an end carbon is not an option. So we call this simply dimethyl, and I dropped an H, dimethyl propane. And in this case, there's no need to say 2-dimethyl propane, because if I had a 1 or a 3, it would be a butane. It wouldn't be a propane anymore. So no numbers needed for this. If I said to you on a little quiz, which probably will happen on Friday, draw dimethylpropane, you would draw your propane, and then as soon as you thought about putting your methyls, you'd say, oh, I can't put it on the end, so I got to put them in the middle. And you would come up with the proper structure with just saying dimethylpropane, no need to say the two. So if the number isn't needed, we don't put it, okay? It's only if the number is needed because of an ambiguous situation. If I just said here methylhexane, you would know not to put it on the first one and the last one, but you'd have 2, 3, 4, well, actually you'd only have 2 and 3 because 4 and 5 would be the same on the flip side, but you'd have 2 or 3, and your question would be, which carbon do I put it on? So we need the number in that case. All right, let's take a look at this last one over here. I'm going to move this. Oh, I draw lines when I use my mouse. That's really sad. I do that every time, right? So let's move that over. Oh, yeah. I remember this fun. Can I clear my screen? I can't clear the screen with that. Oh, that's fun. I can use the eraser, but it's like why would I just use a chalkboard then if I'm doing this type of action? Okay, let's erase the chalkboard. Don't have to clean the brushes, I guess. That's one thing. Okay, look at now I've got the eraser going. It's like I'm new at this tech business. Okay, let's do these. So, what's the longest chain in this one? You guys tell me. Longest chain. Yep. 1, 2, 3, 4, 5, 6, 7, or 1, 2. Oh, you're doing this hard one over here? Let's do this one here. What's that? Heptane. Hectane. Sounds like you're cursing at organic chemistry. Hectane. Anyway, 1, 2, 3, 4, 5, 6, 7. Heptane. Excellent. 1, 2, 3, 4, 5, 6. Just checking, right? So it's a heptane. I agree. So it's a heptane. And 1, 2, 3, 4. 1, 2, 3, 4. It's in the middle, right? So it's in the number 4 position. Sorry? Yeah, we're calling this an ethyl. Excellent. Ethyl. So this is 4-ethylheptane. I could put that ethyl on the number 2 position, right? Or sorry, the number 3 position, okay? And that would be a valid thing, so I need the number. If I put the ethyl in the number 2 position, then it would become the longest chain. So just like I would never put a methyl on the end one, I would never put an ethyl on the second last one, because it would make the longest chain. Now, as soon as I introduce double and triple bonds, that changes things. That's only if it's all single bonds. As soon as I introduce double and triple bonds, then the naming rule changes that could be a case. So we got to watch it. Yes? No, in this case, I was counting both ways to see which would give me the smallest number. But because it's right in the middle, it doesn't matter which way I count from. It's always got to result in the smallest numbers for the branches. That's how you determine which way. Right, so let's take a look at this one here. So somebody told me a nonane. What do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just check here for a second. 1, 2, 3, 4, 5, 6, 7, 8, 9. Either way, it doesn't matter. So we'll go across this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're right, it's a nonane. Nonane, I think Joe was telling us it's a nonane. In terms of groups, I've got a methyl group, and this group here is a ethyl group. And now we've got to pick sides for numbering. You'll notice it's identical. 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. So you might think it doesn't matter. But when you have choice, what are we going to choose? Why would we pick methyl first? Oh, nice try. You could think because it's the smaller one, you're going to pick it first, but that's not what we go to. Whenever you've got a question mark, you default to this. What do you think, Joe? Alphabetical. Whenever you've got a question mark, default to alphabetical. So ethyl, because it's alphabetically first, we'll get the smallest number. 1, 2, 3, 4, 5, 6, 7. We start with the ethyl first, because it's alphabetically first. 3, ethyl, another dash, 7, dash, separate numbers from words with the dash. 7-methyl-nonane. The words all roll together, no space. All right? Okay. Now I'm going to get my eraser out, just like I do on the chalkboard, and I'm going to erase the chalkboard, because this is fun in a non-fun way. Don't erase that one yet. I'm ready to move. Ready to go. It's happening. I'll start with the beginning of the word. Oh, it's faster than an actual eraser. Back this way. Back down to here. Okay, let's take a look at this one. Longest chain, has anybody found it? 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. I didn't do anything exciting, like go down around the corner. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's looking like 9. So again, base name, nonane. Nonane. Now my groups. Goodness gracious. Look at all these groups here, or these branches. What are they all branch examples of? They're methyl. They're methyl groups. Now I need the smallest numbers. 1, 2, 3, 1, 2, 3. Those are identical. But this guy's closer to the left side. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8. We don't, I guess, don't need the 7, 8, and 9, but we get the idea. So now I'm going to have 1, 2, 3, 4, 5 methyls. I need a prefix that indicates 5. So I have to have pentamethyl, 5 methyls. If it was 2, it's di. If it was 3, it's tri. If it's 4, it's tetra. And then if it's 5, it goes back to what we have as 5 carbons as well. So it's pentamethyl. So this is a pentamethyl. Pentamethyl. And now each branch gets its own number. So I need 5 numbers. And so it looks like this. I have 2 at 3. So it becomes a 3, 3. You separate numbers by commas, and you separate words by dashes. So it's 3, 3, 4, 7, 7, dash. So everyone gets their own number. 3, 3, 4, 7, 7, pentamethyl nonane. Nonane. All right? What a great name. Now that's an extreme one, but again, I'm introducing you to all the concepts, so extreme is probably a good thing to do. Okay. Now we've got a cyclic one. We don't include the external branches as the main name, just the chain. 1, 2, 3, 4, 5. That makes this a, cyclopentane. Very nice. I got a branch. If I had 2 branches, I would need numbers. But there's only one branch. So if I say methylcyclopentane, you'll just stick a methyl off of one of them, and you'll always get the correct answer. No number needed here. So this is just methyl, no space in there, but I'm okay if you do it backwards the way I do. I always do it in reverse. Do the base name first, then put the stuff on the front. Methylcyclopentane. All right. I wonder if I can make that bigger. If I have to do this, I'm going to have to make this bigger. Like a huge circle to just get rid of it all in one shot. And just get rid of it all? Like get rid of it? Like say clear writing? Like clear ink? It's genius. I tell you. All right. We'll try that later. I'm a little slow in the technology business. I'm in my 40s, you know. I'm good at tech. Just relax. Okay. 1, 2, 3, 4, 5, 6. A cyclohexane, right? Cyclohexane. Now notice this is not benzene. Benzene has these alternating double bonds. That's a different thing. It may have a ring like 6, but it looks different. Groups. I got a methyl and an ethyl. You don't have to write it down every time. I'm just writing it down to, you know what I mean, to show you what we're doing. So now I do need numbers because they could be at 1 and 2 or 1 and 3 or 1 and 4, okay? One of the branches always gets number 1. Again, we're to the point where it's like, which one gets number 1? And whenever you have that question mark, what do we default to? Alphabetical. So who gets the 1? Yeah, 1 ethyl, 1 ethyl, and what are we at then? 1, 2, 3. Clockwise, counterclockwise, meaningless. Because you can flip these things around. It's whatever gives the smallest numbers. 3 methyl cyclohexane. Okay? So that deals with examples of multiple branches and different branches and how they're numbered and cyclo versions of that have cyclic ones. Now let's just do a quick draw, and then we will get into talking about double bonds and triple bonds and then ones that have the benzene ring. Okay? Let's clear the ink. Oh boy, that's exciting. Okay. So now we're just to, let's draw some structures. And I'll move this over here so we got lots of room. Drawing structures is easy, folks. I've already kind of given you a little heads up about when you did the isomers. Draw just the carbons and leave a little space behind it so you can insert your H's at the end depending on how many branches they have. So when I look at something like hexane, I am going to draw C, and I'm better at it on the board, but you get the idea. What have I done? 4, 5, 6. Okay? Now I'm going to put on my branches a 3-ethyl. So 1, 2, 3. And when I'm drawing, I always go from left to right, right? So 3-ethyl, and you don't have to draw them as separate. I'm going to show you some examples later on that looks like this. Ethyl is going to be C2H5. Just draw it like that. That's good enough. I don't need them separated out. If you did that, that's fine. It's not wrong. But to me, that's valid. That's good enough. That's an ethyl group. When you draw it like this, sometimes we think C2H6, because that's the 2N plus 2. But to give it a bond to stick to the branch, we have to take one of the H's away. So it's C2H5. The methyl group is in the number 2 position, and you can put them all up. It doesn't matter. CH3. You could put one up, one down. They rotate. It doesn't have any effect. Now that I've got all my branches on, I can finish my H's. There's 1 bond there. That's an H3. There's 3 bonds there. That's an H. That's an H. That's an H2. That's an H2. And that's an H3. When we do our quizzes, because I'm going to give you a couple of quizzes throughout this run just to make sure that we're kind of keeping up with the naming, don't forget your H's. Sometimes we get in a hurry. We draw all those C's. We think we're done. Don't forget to go back and do the H's. Butane. Some of you are just sitting there, which means you've tried drawing them. That's great. It means you kind of went home and tried them. That's fabulous. Butane. 1, 2, 3, 4. 2, 2, 3 trimethyl. CH3, CH3, CH3. Now the H's. H3, none, H, H3. Drawing is easy. Drawing's kind of fun, right? All you're doing is building it. You don't have to think quite as much. So we got a cyclopentane. Now, I'm going to introduce you to a little shortcut. And you've already seen it when I showed you that little program. I have no problems drawing cyclic structures as just the shape. So if this is cyclopentane, I will allow you to just draw the pentagon and assume that it's got 2 H's hanging off the side. We don't need to see them. So this is a little introduction into the shortcut version, but I do still want you to draw the chains out like this, because I don't want you to get, it can be tricky when we get very complicated. But for the ring, if you want to do a shortcut, that's great. But if you have here a bunch of CH2s, that's fine as well. 1 ethyl, so we'll put that as 1. C2H5 is our ethyl, and 3 methyl. So 1, 2, 3, CH3, and I go counterclockwise again when I'm drawing just because that's easiest. So 1 ethyl, 3 methyl cyclopentane, Excellent. That gets you full marks right there. Okay? No need to show me. But if you had that, right? Let me just change the color just to illustrate it. If you had a CH2 and there just a CH, right? And here a CH2 and again a CH and a CH2, all right? That's great. That's great. That's fine. But you don't need that. Okay. And what do we got? A heptane and a diethyl. All right. So 1, 2, 3, 4, 5, 6, 7. And I got a 1, 2, 3. So I got a 3-ethyl, C2H5. And I've got a 4-ethyl. And just because I'm out of room up top there, C2H5 and an H3, an H2, an H, an H, an H2, and I'm getting squishy in here. You guys are better. You guys will be better. Whoops, that's an H3 on the end. Boom. Okay? All right, a little squishy in there. That's because I'm having a tough time getting my spacing on this machine. Are we okay with branch chain alkanes? All right? So now I want to continue on and introduce you to, actually, I'm going to get rid of this. I'm going to clear this just to clean things up before I move on. And I'm actually going to close this guy out. And then we will go to the PowerPoint. See, that is high-tech, folks. That is high-tech stuff. We'll start that there. Okay, good. So now we're ready to talk about alkenes, alkynes, and aromatics. And I hope to get done this today, but we'll see. If we don't, we roll on and we just move it over the next day. I've already introduced you to these terms the last time we talked about this stuff. Alkenes and alkynes still fall under the group that we call aliphatics. Alkenes contain double bonds and alkynes contain triple bonds. Okay? So I'll introduce you to some of them. We'll talk about some isomers of them, and then we'll practice drawing and naming them just like we did. So a little bit of information about alkenes. They contain at least one carbon-carbon double bond. They can have more than one. We would have a diene then. And literally, that's the way it would go in the name. We'll see some examples of that. We say that they're unsaturated. The alkanes, the term we use to describe those, are saturated. It means that it is right full of hydrogens. It cannot have any more. But as soon as you introduce a double bond, you have to actually remove two hydrogens from adjacent carbons so that they can make the double bond. It means that they're not full of hydrogens anymore. We say it's unsaturated. Right? So again, we had the discussion about fats, right? Saturated fats and unsaturated fats. An unsaturated fat simply means that it's got double bonds in that carbon chain on that molecule. I'm going out on a limb, but I think you can even have polyunsaturated fats, and I think that means you can have more than one double bond on that chain. No? I'm grasping for help. You said that last time. Yeah. No, I didn't. No, you were saying things so fast. And I hadn't talked about alkenes for a while, and I forgot. Don't be so mean to me. You guys are pretty mean to me. Anyway, did I get it right? Has more than one double bond, makes it a polyunsaturated fat? All right. Did we determine whether that was bad or good for us? Oh, we like polyunsaturated fats. Where would I find some polyunsaturated fats? But I like butter. Well, then where am I going to find some polyunsaturated fats? What kind of oils? Like olive oil and fish oil? All right. Olive oil-based butter? That's interesting. All right. All right, I'll get healthy today. let's continue on talking about some chemistry though. The name, instead of it ending in anes, like ethane, it ends in ene, right? Okay. So, don't mind that. That was just a screw up. Again, a similar type little table. We're going to go over some of the example ones. So again, you don't need to draw all the lines. Just put number of carbons. Actually, yeah, we will put the structural formula and then the condensed structural formula. Yep. Yes. Yeah, go ahead. You could use an eye wash station. That'd be exciting. Well, if you need to, it's right here. Okay. So number of carbons, structural formula, condensed structural formula, chemical formula name. We're doing the same type thing as we did with the alkanes, except with the enes. It looks different than on your sheet. I've changed it. Yeah. No, I haven't done that yet. No. It is terrible. You know the way I fly. It's, like I said, the course is evolving online. It's ever changing. All right. Number of carbons. Well, you can't have a double bond if you only have one carbon. So there is no such thing as methene, because you have to have two carbons to have the double bond between. So we actually start with two atoms, two carbon atoms. Structural formula, C, double bond C, H, 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 H. And condensed structural formula, CH2, double bond CH2. So we squeeze it together there, okay? Its overall chemical formula, C2H4. And what are we calling this thing? How many carbons? So what do we call it? F, right? F. And it has a double bond, so we have to put an ene on the end. Ethene. Ethene. Okay? This historically has been also called a vinyl molecule. And I'll talk more about that a little later on. But that's an old name for it. Ethene is the new name. But I'll talk a little bit more about that later. 3. C. And it doesn't matter, I'll put the double bond there. H. This has H3, and then it's got another H off to the side there. Notice these are all sp2, right? The guys that are flanking the double bond are sp2. They're triangular planar shape. This guy here is an sp3 hanging on the end. CH3, CH, double bond, CH2. C2H, how many of them are on that one? Oops, C3H6. What's the general formula for alkenes? How many H's are there compared to the C's? 2 times. So CnH2n. There's no plus 2, because we had to take the 2 away in order to make the double bond. That's how you could actually check to see if it's saturated or unsaturated. Let's say I give you a formula that has a whole bunch of C's and H's, and you do the quick math and you find that it's n plus 2n plus 2 for the H's, then you can say, hey, that's saturated. That's an alkane. But if you end up with just C and then N and then 2N, oh, you can say, hey, that's unsaturated by 1 unit of unsaturation. You could stick 2 more H's on there, okay? You'd also find that to be the case for the cyclic ones. To make a ring, you actually have to take 2 H's off to close the ring up at the end, right, to do that type of thing. So you'd find that that's the truth for cyclic alkanes as well. What's this going to be called? Prop what? Propene. All right. Next, 4. Now we run into trouble with 4. I'm actually going to draw 2 structures in here. Actually, no, I'll only draw 1, and I'll put the second one on the second page. The first one, let's put it as C, and I'm going to put the double bond right away. So H, double bond, and then C. And then that's going to have a CH2 and a CH3. And this H is going to go up here. Actually, I've drawn the condensed one. The other H, oh no, that's, what have I done? That's H2, isn't it? I don't have enough bonds here. Okay, fixing. That, you know what I'm tripping over here? Because I want, and now I've got a different color. Because on my next situation, I have these isomers that Emily really didn't want to talk about, and I thought about it all last night. I was getting all excited so I could disappoint Emily by talking about these special type of isomers. Okay, so that's not a bad picture right here. C, two H's, double bond, H, and then CH2, CH3. Okay? And in terms of the condensed structural formula, CH2, double bond, CH, and then we keep going down the chain, CH2 and CH3. Okay? And C4H8. And now we've got to introduce a special naming system, because I put the double bond right here after the first carbon, but there's no reason why I can't put the double bond over here after the second carbon. Okay, so the position of the double bond becomes important. This double bond comes after the number 1 carbon, so we call this 1-butene. I now am putting a number right before the parent name to indicate the position of the double bond. Okay? Yep. Oh my goodness gracious, that's an exciting question. Like, so how does that position of the double bond affect the characteristic of the molecule itself? It will subtly, but exactly how? I can't answer that. I was terrible at organic chemistry. Except move the double bond over. That's exactly correct. Yep. And what do you think we're going to call it when we move it over to butene? But there's 2 forms of 2-butene, which I don't usually introduce, but yeah. So let's talk about the 2-butene. Let's put the double bonds in here. So again, this is 4 right here. Another one for 4. So the structural formula, I've got it in the middle now, which means I've got a CH3 out here, and then I've got an H this way. And now I've got a decision to make, because remember I've taught you that you can't rotate a double bond, because that pi bond, right, remember it's got the attachments above and below, and if you rotate it, you break the bond. So double bonds don't rotate very well, which means I can either position the next CH3 up here or down here, and they actually make a difference. Let's put it up here, CH3, and then the H, okay? Now, when you do a condensed structural formula, it's going to look exactly the same. This is going to be CH3, CH, double bond, CH, and then CH3. And if I do the other version, again, this is 4, C, double bond C. This time I'm going to put the CH3 up top, and I'm going to put the other CH3 down below, CH3. H, H. Condensed structural formula is going to look the same. CH3, CH, double bond CH, CH3. And these are all C4H8, C4H8. And you're right, these are both 2-butenes, but one of them has the CH3s together, and one of them has the CH3s on opposite sides. When we wouldn't call these things structural isomers, because they have the same connection and they've got the same chemical formula. That's what our definition of structural isomers were. These two are actually what we call geometric isomers. They've got the same connections and the same formula, but due to the restricted movement of the double bond, they actually have slightly different geometries, even though their connections are the same. We call them geometric isomers. The way we name geometric isomers has to do with the position. So right here, this thing shuts off every time. So right here in this one, we've got opposites. Computer's catching up with me. It's a little slow. We've got opposites. We call this the trans isomer. This is the trans. Trans means opposite, right? You take the Trans-Canada Highway, you want to go to the opposite side of Canada. Trans means opposite. We call this guy, when they're together, cis. I have no idea where that comes from. So this is actually called cis-2-butene. And this is called trans-2-butene. I don't know. We'll see. All right. We've encountered our naming systems. I could do a 5. There would be some cis and trans guys. I'm not expecting you to know a lot about this cis and trans thing. I just wanted to introduce it to you. If I asked you a question on the test about cis and trans, it would be directly about the butene. I wouldn't, mix it up and try to be too mean on you. Okay? All right. So let's not worry too much about 5 and 6 and 7. You're getting the idea, I think. So general formula, adding a double bond removes a position for a hydrogen on either side of the double bond. So the general formula becomes NH2N. Yep.
We have to learn about the branches.
Yep, we're going to do examples of that right now. Yep. So the general formula is N, CN, and H2N. And that's for alkenes that have one double bond. If it's got 2 double bonds, then another 2 would have been taken away. Then it'll become 2N minus 2. Then you've got 2 units of unsaturation. One to get you down to the 2N, and then another one gets you minus 2. We used to do experiments in university where you would get some formula, and then you'd figure out how many units of unsaturation, and then you'd have to do some tests to see if they're rings or whether they're double bonds, because certain tests can test for double bonds and certain tests can test for rings. Oh yeah, lots of fun. Then we would eventually try to figure out what the structure was. Now in my next series of slides, I go over how to name them with branches and all that type of stuff. And I've turned this into a handout as well, so we don't have to draw all the pictures. But on this handout as well, I've also got the rules of naming alkynes, triple bonds. And the rules are very similar. So I'm going to introduce you to alkynes first, and then we'll talk about alkynes, and then we'll do all of the naming in one shot to finish off the class. Okay. So like I said, naming alkenes is what I normally do next, but let's save that for the handout. Yeah, blah, blah, blah. We'll go over all this stuff on the handout. Let's now first write down about alkynes. They're also unsaturated. We would say it has 2 units of unsaturation. So now I've got things like ethine and propyne. Again, when I get to butyne, I would have to have numbers to position the triple bond. So again, I'd have a 1-butyne and a 2-butyne. Yep. sorry. Oh, then we would have a situation where you could have an ene with an ein in the naming. So you'd get a weird situation where you'd have non, then you'd have a number for the ene and a number for the ein. It would be non something ene something ein. Tell you where to put the ene and where to put the ein. We'll do some examples, maybe not one that complicated, but we'll do some examples to name these things. But you're right, you could have double bonds with triple bonds. If you can imagine it, and it follows all the rules of the drawing of the molecule, you could build it if you were a really good organic chemist. I couldn't build it because I don't have those powers, but someone who really knows their stuff could build it. Okay. General formula, because we have to remove another 2 hydrogens, CnH2n minus 2. That's if it's got 1 triple bond. There are no geometric isomers for triple bonds. They're sp2 hybridized, which means they're linear, right? They're all in a line. All those molecules are straight linear. So there is no flipping situation. There's only geometric isomers for double bonds. So single bonds, there's no geometric isomers because they can spin around. Triple bonds can't spin, but they're linear. So there's no way to have a opposite or a together, right? A cis or a trans. So we don't have to worry about that for triple bonds, just for double bonds. And I think we're getting to the point where we're going to practice naming. I'm just going to look ahead here for a second, see if it says naming. Yep, good. So I'll bring that back so that you can finish that off, and I'll give you the sheets. Okay. So the examples, I try to make the examples that was on my PowerPoint. I'm trying to build my handouts to be very much the same. Some of them aren't exactly the same, but don't worry about it. You've got the sheet here, and we're going to work together on that. So I'm now going to switch back to this PowerPoint right here, naming branch-chained alkenes and alkynes. It's actually easier to name alkenes and alkynes. The parent chain must contain the double or triple bond. So it's now not the longest chain necessarily, but it's the longest chain that contains the double bond or triple bond. Because remember, we called that special group of atoms the functional group, and the functional group must always be in the parent name. It's what defines what the molecule is. When numbering, begin with the end that's closest to the double bond or triple bond. So now our numbering becomes even easier because the double bond always kind of trumps the branches. Because again, it's the functional group, and the functional group gets the main, gets the main characteristic of that molecule. So we give it the smallest number. So easy. Main chain has a double bond or triple bond, and it gets the smallest number, and then we in a ring structure, number will always start at the double bond. So if you've got a ring with a double bond in it, that defines number 1, with number 2 being the next guy. We'll do some examples. And then if we have multiple double bonds, we can have dienes and trienes, all right? And we'll do some examples. Name the branches as before, put everything together, and away you go, all right? So let's zoom in here. I know I made these pretty small. My next handouts, I don't have them quite as small, but I think you can see them okay, can't you? Can we see them okay? All right. So let's slide this thing over here. Let's name this guy right here. So I've got a chain here, and again, you might think 1, 2, 3, 4. You're right, it is 4. But right away, that double bond indicates the smallest number. So there's my 1, there's my 2, and there's my 3. So because we've got 4, I always name that last one. Anything that's beyond 4 needs numbers, right? We saw that when we did 4. We had a 1 butene and a 2 butene. So Anything that's beyond 4 needs numbers. If it's 3, then you don't need it. It's just propene because there's only one spot it can really go. So this is a 1-butene. Now we need to name our branch. It's a methyl. It's in the number 3 position. It's a 3-methyl-1-butene. All right? Here we don't have any branches. Nothing to worry about for branches, but we've got 2 double bonds. Again, we need to number because we need to position those 2 double bonds. This is a 1, 2, 3, 4, 5, 6. All right? Now, it's a hexene, but it has a double bond after the first carbon and a double bond after the third carbon. So this is a 1, 3 dash hexa, and we put the A on the end of the hex, right? Just like where we said but, well, I just said but it's actually buta, and it's actually tetra, penta, hexa. If it's ending with something like ene, we don't put butaene because the E and the A don't work together very well. So this is hexa. We put in a di, and then we put the ene. So in this one, we've got the 2 numbers, and we've got the di to represent 2 double bonds. Hexadiene. Okay? Let me know if you want me to stop anything, because I'm going to clear this screen here. Clear the screen? Clearing the screen. And Smart Ink is off. Oh, that's because I'm still running this thing. Get out of the way. You get out of the way. Smart not connected. Clear Ink. Still works. Yep. Yeah, I'm going to move this guy over. Okay. All right. Numbering from this end, right? 1, 2, 3, 4. Oh, look at there. There's a C3H7. You might think the longest chain is 1, 2, 3, right? And then I've got 3 more, 4, 5, 6. But I've got to have all the double bonds in my chain. So you might have thought 1, 2, 3, 4, 5, 6 is the longest chain, and it is, but I've got to have all the double bonds in my chain. So even though I only go to 5, I don't choose that because all double bonds have to be in the chain. What kind of a branch is this? Propyl. So base name, 1, 3. And what am I writing as that last part? Pentadiene. Pentadiene. So we've got the main chain. Where is my propyl group on the number 3? It is a 3 propyl, and I dropped my dash in there. 3 propyl. I've got a cyclic structure. My 1 is going to be either here or here. And I always then count 2 on the other side of it. But what's going to give this the lowest number? That's the question. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6. So I go 1, 2, 3, 4, 5. You start at the double bond and go across it to get to 2. Don't head the other way. So this is, and you don't need the number in this case to say that it's a 1 cyclo, actually how many are in this chain? So you don't need 1 cyclooctene because it defines the 1 position. You just need cyclooctene. Cyclo, and you do put 2 O's, it's funny. Octene. So cyclooctene, it looks like cycleuctene, that's funny. But that's how you write it, cyclooctene. And this is a 5-methyl. 5-methyl Oops, no dash in there because it's a continuous word. There's no things in there. So 5-methyl cyclooctene, and I did a really bad job of trying to get that to come together, but if you have a space in there too, I'm not concerned about that. Okay? All right, that's a fun one. Let's clear the ink. Let's move along to the next one. Oh, so here we're drawing some enes. Again, drawing enes are easy. Drawing anything is easy. 1,3-pentadiene. So, oops. I got to change my pen here. Did I miss one? Did I miss one? Oh, we did that as an example? We did it when we did an example?
Well, like that was the first one we made.
So it's the same thing? Oh. Oh, there you go. I didn't even realize that. Okay, then let's skip it. I was just cutting and pasting. Didn't realize it was the same molecule. Good eyes. So B. Pentadiene. Again, same thing. I just draw 1, 2, 3, 4, 5. 1, 3. Put in my double, oh, that's a horrendous double bond. Put in my double bond after the 1 and after the 3. Now after the, on the 2, I put a methyl, CH3. And then I load up my H's just as before. This guy has 2 bonds, so I need an H2 there, right? This guy has 4 bonds, no H's. This guy has 3 bonds, he needs an H. This guy has 3 bonds, needs an H. And this guy, H3. Okay? For this double bond right here, notice I've got an H and an H and then 2 different things. This would have cis and trans isomers, but I'm not going to make you draw those. But I could have this big branch sticking down and this big branch sticking up. It would have cis and trans isomers. This guy has 2 H's that are identical. There would be no cis and trans isomers across that double bond. I'm not making you worry about that stuff. I'll only make it an easy one if I'm going to get you to do that. Okay? I'm looking to clear. Moving over for one more. Cyclohexene, 1, 2, 3, 4, 5, 6. Just put the double bond somewhere to begin with. That defines my, oops, I didn't mean to write that. That defines my number 1 position right there. Get rid of that dot. That defines my number 1 position. So that's 1, 2, 3, CH3. You could have went the other way around, 1, 2, 3, and put it off of there. Okay? Going to clear. Scream at me if it's no good. Going to move down here to some double bonds, triple bonds. Okay. I didn't leave a whole lot of room here. I think I'm going to write the name on the side here. Looking for the chain 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Doesn't make any difference, right? So it's looking like it's a pent, and it's a pentyne. You might think, hey, let's count from this end because it's going to give me the first branch. But remember, the triple bond or the double bond gets the lowest number. That means I have to start from this end. 1, 2, 3, 4 for my branch over there on the 4. So there's 5 in total. So what's my base name on this? What's the end part? It's a pentyne. It's a pentyne. But I do need a number to define where that is. Yeah, it's a 2-pentyne. And now I can have a dash here. And now I need my branch. It's a 4-methyl. You know what? Actually, 4-methyl. That's good. That's a good name. But you know what? We really don't need that 4-methyl because there's nowhere else to put that methyl group. I can't put it there because there's no more H's. I can't put it there. I put it there, it makes the chain longer. I wouldn't mark you wrong. That's the subtle one. But technically, you don't need that 4 because there's only one place that the methyl can go. But I wouldn't be picky on that. But you technically don't need the 4 on that. Clearing. Can I clear? Clearing? Clear. Moving over. Which one's my number one carbon? What side? Left? Yep. Because it's got to have the smallest number, right? 1, 2, 3, 4, 5, 6. With a branch up there. So what's my base name? 1, 4. Hexa, because I need to put something before. Diene. What a great word. Hexadiene. That's fun. It's like we're learning a new language. So, and then what goes in front of this? A 3-ethyl, right? It's an ethyl? 3-ethyl. And if we looked at, we might be restricted on that as well. And we are. Look at, there's no other places to put that, but I'm not going to get picky on that. 3-ethyl. Looking to clear. We okay, clear? Clear. And now I think I've got 1 or 2 to draw. Just 2 to draw, maybe? 2 to draw. And then I got to go back to my PowerPoint for your homework. And yeah, we'll stop there. Again, drawing is easy. Draw your C's, put your double, triple bonds, put your branches, fill with H's. So penta, 1, 2, 3, 4, 5. It's a 2-ine, so there's my triple bond. And I'm not very good at this on the computer, but it's okay. And I need a 4,4-dimethyl. 1, 2, 3, 4. CH3. CH3. And then load with H's. This is an H3. That's got 4 bonds. That's got 4 bonds. That's got 4 bonds. H3. Heptadiene. 1, 2, 3, 4, 5, 6, 7. 1. Double bond there. 2, 3, 4. So it's after the 4, right? Our double and triple bonds go after the number. A 3-ethyl, 1, 2, 3, C2H5, a 6,6-dimethyl, right down here, CH3, CH3, and what do we got? An H, right? I need an H on that guy. 1, 2, 3, 4, no H's on the second one. 1, 2, 3, a single H on that guy. No H's, no H's, no H's, H3. All right. Questions, concerns on drawing the enes and the ines? Okay, so I'm going to clear the ink here. I'm going to close that up. We're going to skip the examples that are on the PowerPoint because I've changed things. Yeah, beautiful. Yeah, we did that. That's great. Did that. Whoops. Boom. There's some homework. And it looks like I still have to talk about aromatics for tomorrow, which is fine. I wasn't sure how quickly I could go through it. I was hoping that using the sheet, the naming would become easier and quicker, but well, it's no big deal. I do plan on having a quiz, which will have about 5 structures you need to name and 5 structures you need to draw, and that will be on Friday, and it will contain anes, enes, ines, and it will also contain the aromatics that I teach you about tomorrow. All right? All right? And you'll be fine. The aromatics are not going to be very complicated. It won't be too tough to have a quiz then the next day. You'll be okay. Okay.